I'm Varun Shah. I work as applications engineer at Texas Instruments, Dallas. Uh, Everybody knows the abstract, so I'm not going to waste time since we have only 30 minutes. So my presentation will be covering the following things. So what I'm going to do today is I will guide you guys through what we are doing at TI to accelerate the performance of Qt on all our hardware based on ARM processors. So let me tell you first what Texas Instruments do. So TI is basically a semiconductor company. We are into designing and manufacturing wide range of embedded processors, including ARM-based processors and DSPs. So we have customers who take our hardware, develop products and applications on top of it. And we support variety of platforms, and Qt is one of them. So we can classify, with respect to Qt, the whole embedded platform into two broad categories. One would be ARM and second would be DSP plus ARM. So Sitara is one product line we offer under ARM. It offers ARM 9 and Cortex-8 based architectures ranging from 300 megahertz to 1+ gigahertz. And on the DSP side, we have DaVinci and OMAP product line. We offer ARM, same as the Sitara portfolio, as well as we have DSPs, fixed and floating point, as well as we have video accelerators, which are programmable and capable of running various video codecs on top of it in different resolutions. So, TI's open source presence. How many of you are aware about BeagleBoard? Not few, not many actually. Surprising. So BeagleBoard is one of the community boards based on TI's 1 gigahertz Cortex-8 processor, and it is quite famous in open source, I will say, and I can even tell that it is one of the standard platforms for Cortex-8. Besides that, we also have different types of boards available, like Leopard board, which is targeted for imaging, and it is based on DM365, having a DSP in it, and ARM 9, as well as we have Hawk board, which is targeted for industrial automation applications, again based on ARM 9, having a floating point DSP, and it is based on OMAP L1. And I am not sure what is L. I guess it is low power. In order to get more information on different software projects we are having on using TI technology, you can always visit designsomething.org. By the way, Migu is one of the projects that is running on BeagleBoard, and probably, I guess, the testing of Migu on ARM is mostly done on BeagleBoard. I'm not sure. I'm just quoting what I've read on the internet. Now let me start this way. In March of in 1968, Intel's co-founder Gordon Moore, he actually cited in one of his papers that the number of transistors involved in a chip will double every 24 months. Well, this has remained true so far since 1968, and just not for desktop, but also for the embedded platform. So today, with the boost in computing capability of embedded platform, the use of desktop graphics is possible on the embedded platform. So rich, advanced custom GUIs are omnipresent on the handheld devices, and it is basically eye candy to our customers. So you and I, if we go to the market and we have a choice, so we will select mostly the products which is having very advanced GUIs. So this offers, so advanced GUIs definitely offers product differentiation and an edge over their competitors. So we know how our cell phone market whole space changed with the introduction of iPhone and touchscreen and very fancy cover flow and GUIs. So on our platforms, what we are seeing is any customer coming and wanting to develop an application, they are requesting support of advanced UI and applications framework. So basically, we got hunting for a good framework that would solve our purpose. So last year, in March of 2009, Qt was released under the LGPL version 2.1 licensing, and that actually caught our attention. LGPL in TI is a very enterprise-friendly licensing, and we love it somehow. I'm not sure again. It's something to do with legal. So we actually started studying the studying the entire framework, and we knew that we found a very suitable framework we were looking for, that we can offer it to our customers. So Qt was chosen because it has very feature rich. I shouldn't go 2D, 3D, multimedia, WebKit, and so on. The most critical aspect was it was able to leverage the hardware capability of our platforms, of the TI platform. It is extremely good user community, the active community, open source, and Trolltech developers, and very good support. So this is another important feature whenever you are a hardware vendor. You need to have a support. When you are in problem, your customer developing application on top of your hardware is having a problem, they always need somebody to go to seek help. And so far, I should appreciate the Trolltech developers that they have done an amazing job at supporting our customers, and thank you for that. So one of the important feature, as I mentioned, was able to leverage the hardware capability. So why do we need hardware acceleration? Well, everybody knows code path. Any code executing in hardware will have better efficiency. It will save the ARM CPU, and definitely power will be saved, and we will have a lot of other advantages. We will have more headroom on the ARM, and what does that mean is we can implement more features since ARM is sitting free and all the hardware is doing the hard work. And more features implemented in a product means a product differentiation for anybody, any company developing a product. So that was one of the important feature. And also, TI has quite a few hardware feature that it offers in the SoC. So on studying the Qt architecture, we actually nailed down 3 important hardware features that could be leveraged to accelerate the performance of Qt. So the first one would be the PowerVR SGX. So Qt has support for the Chronos open standard 3D graphics APIs like OpenGL, and PowerVR SGX is one of the supported backend. And 3D graphics core, the SGX, is present on the TI chips in all the product line. So in the OMAP, we have 3515, Sitara we have 3517, and DaVinci we have 3715 and 8168 having SGX clocked at different speed. If you guys are not aware, then SGX is basically a 3D graphics core IP that TI licensed from Imagination and provides on its SoC. So the drivers that come with the SGX has support for the Chronos open standard that I just mentioned, OpenGL ES 1.1, 2.0, OpenVG, and TI has implemented its own texture streaming extension. So what is that extension? So what you are seeing here is a cube that is rendered using the OpenGL on the SGX, and the video is being decoded by our DSP, and it is texture binded onto the faces of the cube. So this entire support is there using SGX in the drivers offered by the TI. So basically 3D graphics support can be enabled in Qt by simply compiling and building Qt with the SGX support, which cannot get simpler than using this following 2 switches, giving OpenGL ES2 and defining the plugin graphics as PowerVR. And here you have the 3D acceleration. For more information, you can definitely visit the wiki page that I've written, and probably I'm having the highest hit, one of the highest hits in my TI wiki on this page, and it has been verified by thousands of users so far. The second hardware feature that we can leverage is Neon. So we recognize that last year we have issues with the 2D performance. So TI went ahead and hired a third party, and we actually worked on accelerating the 2D graphics acceleration like scaling, alpha blending, solid fill, ported off, all the basic graphics operations. And we integrated the 2D graphics Neon acceleration in Qt embedded in raster paint engine. And any application, any Qt application today running with the Neon backend on TI hardware is having 2x to 3x performance improvement. And in some cases, if the code path being used is more on the Neon side, then we are seeing higher acceleration. So Neon, what is Neon? So this is a Cortex-A8 architecture, and this is a Neon unit having its own execution pipeline inside Cortex-A8. So you will see that this is the execution pipeline of ARM, and Neon is having its own execution pipeline. It simply shares the cache and the CPU clock with the Cortex-A8, and it is capable of doing DSP operations at a higher rate as compared to ARM. The third hardware feature that could be used from TI SoC was the DSP. So as many of you might be aware that TI is by Gene, a DSP company, and we are one of the leaders in global leaders of DSP. So definitely we should extract that in our framework. So I will classify the use cases into two categories. So let's start with the multimedia use case. So when we say multimedia, it is audio and video encoding, decoding. So in Qt Embedded, the multimedia framework is using GStreamer library as a backend. What is GStreamer? GStreamer is an open source library that is used to develop the multimedia applications. So if used unmodified directly from the open source, what will happen is the audio and video codecs will be executed on the ARM. And we will be able to decode the video frames with the resolution as good as D1. However, TI is having fixed or floating point DSP as well as programmable video accelerators, which is capable of running video and audio codecs in hardware. So what we did is we actually went and contributed a TI plugin in the GStreamer such that all the audio and video encoding decoding is done by DSP, and the decoded or encoded buffer is simply given back to the ARM. So ARM is here sitting free, and you are able to get all the audio and video decoded for free. So the benefits. First is optimized buffer management because we are dealing with video and memory. So very optimized buffer management because you are using the DSP libraries made specifically for the hardware. So if you use multi-threading, then ARM and DSP is running in parallel. Encoding and decoding of high resolution is possible. So today our chips are capable of decoding as good as HD resolutions, like DM365 and upcoming 368 and so on. So HD encoding decoding is possible. We are able to take advantage of the other hardware features like resizer, eDMA that further goes and improves the performance. And again, ARM is free, doing nothing, while DSP is doing all the hard work. So more features can be implemented in your product by using DSP backend. So if you want more information, again, you can always go back and look at gstreamer.ti.com for more information. And the second non-multimedia use case. So when I say non-multimedia, so I'm talking of all the computations, very heavy computations in your application, in the Qt application. So that can also be offloaded to DSP because again, any heavy computations, DSP is good to do that. So I know people will complain that DSP is not easy to program and how can we do it using Qt. So our DSP architects knew that, and last year again we made efforts to make a tool called C6 Easy Run. So what does this tool do is, it allows you to create an ARM application that runs entirely from the DSP. You don't need to write any DSP code. Simply write the any normal application and use this tool. So how are we using this tool? So suppose this is your code with critical.c having all the computations. And what you do normally is you use the GCC toolchain and compile it, link it, and generate the ARM executable. Now, use of this tool. Separate this file, run it using this tool, generate the library, take these files, generate the object code, make changes to the make file so that it links it against this library, boom, you have ARM executable that offloaded the entire uh, calculations on the DSP without even coding a single line in DSP. So this is the advantage of this tool, and this is what we have come up, and that was released just 1 month back, and it is free again. So one of the case study what we did to use this tool was Mandelbrot. So Mandelbrot is one of the example that comes in Qt. So we took the calculations that does the Mandelbrot frames, that calculates the Mandelbrot frame. We used this tool, offloaded it to the DSP, ran that again, and we saw improvement of 30 to 35x as compared to running it on DSP. Without writing a single line of DSP, we got it 30x. So the tool is so easy to use. These are the things that come in the package of this tool. Simply use this, generate a O file, generate a library, and link it against the final executable. You are done. You are having the DSP acceleration. So I present the final Qt framework that we have worked on, and that is accelerated using all the hardware features. The 3D done by the SGX, 2D operations offloaded to Neon, I will say accelerated by Neon, all the multimedia done by DSP, and computations of Qt app done in DSP using this tool. There are more room for improvement. We can take the GUI, the transformation calculations and other things, like perspective transformation and other things that is having calculations of matrix, and we can offload it to DSP. However, that is our roadmap. We may do it, we may not do it. We have to evaluate it, but things are possible. Using DSP, we can accelerate Qt further, GUI and non-GUI and other things. So we love Qt. Proved. 1 year I worked on Qt. People used to make fun of me. I should be on the Qt payroll and not TI's payroll. However, we went a step ahead and included the Qt SDK with all the 2D, 3D graphics and multimedia acceleration that I just mentioned in the TI's DV SDK that is shipped along with our platforms, and that user can download it for free to use it on our platforms. So any customer developing a Qt app with and want to run it on our hardware, they have to simply do this: set up the cross compilation environment from the guide, run qmake minus project, qmake, that is a normal drill, and you have Qt application having all the acceleration that I just mentioned for nothing, like no work, everything is out there. Simply drop the binaries on the target file system and everything is running great. Out of box platform demos. So since we worked on Qt so much, we have to we needed to have demos to showcase all the capabilities of our hardware. So what we do now in TI is Qt is used extensively to create and deploy all the out-of-box demos that showcases our hardware's capability. So I will go through few of the projects that we have done. So one of them is Matrix Application Launcher. So as the name suggests, whenever our EVM boots up, it boots up into this screen. So any customer getting a delivery fires the EVM after, and they see this screen, they can play around in this. They can play with this demo. So if they click ARM, they will get all the applications that shows the benchmarks. 2D graphics, it will launch the 2D demos. 3D graphics, it will launch the 3D. Similarly, we have other things like multimedia, and we can clock the board at different speed, can test the USB, Ethernet speed, etc. So this is made in Qt using WebKit. It is touchscreen enabled, and it is running on virtually all the platforms that supports Qt. And it is, of course, a part of DV SDK too. So second is the industrial demo that we made. Again, this is very standard demo that you all have seen. We have just automated the needle to give it more like a tachometer look and more like a damped oscillation look and so on. So now we needed to show customers how to use our DSP along with Qt. So we actually came up with this demo called FFT GUI. We haven't came up with the name. It is still under process. Progress, and I have made it. I left it halfway while I was coming here. However, I'm presenting the very first drop. So I made it using Qt and QWT graph library. So far I have worked for 2 weeks and I was the only one. So what we have done is, ARM is doing all the FFT GUI rendering. We have a sync app that is running, that is syncing the FFT and FFT, our GUI and the FFT algorithm running on the DSP. So what happens is, it takes the input, calculates the FFT, gives it back, and FFT shows the input and the output. Something like this. So this is the input. Let's say this is the random signal, but it is having output. This is the features that I've implemented: zoom in, zoom out, reset, save. So save does nothing else but takes the screenshots and saves it into the file system. Stops the demo, starts the demo, displays help, exits the demo. Hide control panel basically makes this whole thing full screen. And I also implemented a very iPhone similar error boxes where it is having transparency and good looks. Anyways, I just made sure we have aesthetic look on it. So this is running at HD resolution on one of the chip that is coming, that is going to be announced very soon, and this will be the out-of-box demo for that. Another demo we made for medical imaging customer was the ultrasound demo. So in this, what we are having is ultrasound algorithm is running extensively on DSP. It takes the input from the sensor, does the Doppler and other ultrasound stuff on it, and displays it onto the video layer. And ARM Cortex-A8, it is rendering a UI using which the user can basically control the parameters of the algorithm. So something like this, and it is being rendered on the frame buffer. Now this comes to the concept of overlays. So one is on the frame buffer, one is on the video layer. Now TI's hardware, I'm not sure if other hardware is having it, but TI's hardware is having something called DSS, display subsystem hardware. What it does is, it takes the frame buffer, does the alpha blending and puts it onto the video plane. And it is done in hardware, not a single cycle of ARM is being used, and this is the output. This is how the final output looks like. So on the background you are seeing the ultrasound output, and on the foreground what you are seeing is the GUI, which the user can touch, control, change the parameters and get rid of. So this is the final output of the demo. Well, this is it I was having. So everything that I talked about, you can definitely go to these links, have more information about it. And definitely, if you have any questions, you can always go to our forums, e2e.ti.com, where we will reply to you. We'll try to reply you as soon as possible. And we have so far the good turnaround time of 48 hours. So I'll be taking questions. Wow. Oh, thank you. I was like, huh?
Okay, maybe I didn't get it right, but the point where you had your tool doing this math calculation things, do I have to provide several versions if I do want to provide the same program for an ARM processor that does not have your DSP extensions? You said you had to change the makefile and rebuild it, that it links against your special library. So that's not something like a plug-in concept where your library extends the existing ones.
No, actually, this is I understood what you're saying. So this is basically a tool. This is not a plug-in to Qt. So we have to do everything outside.
Not to Qt, okay.
Yes. So you have to change the .pro files to take the this library. So what we did in Mendelbro was this. So we have an automated build system. So we have to make sure that it is built automatically. So what we did, we actually made changes to the PRO file size that this file generates the library using this tool, and we made changes to the PRO to include libs plus is equal to this library, and when that app is being compiled, it basically links it against the library and it is good. So from the PRO file, we remove this file as a source, and simply instead of that, we put it as a library, and that is the change we did, and then use the Qt make system, and you're good.
So have you been mostly using these extension points in Qt to add these optimizations that were already there? Or have you had to change Qt and say, okay, if we put this plugin here, then we can actually add Neon here? Have you had to change Qt to support these things, or was it already there?
Yes. So you're talking about the 2D, right?
Well, I mean, about any of these, there are a
Yes.
few different points where you've kind of plugged the hardware features
let
in.
me tell you. So this is supported just by the switches, and if you provide the you have to provide the paths in .conf file, and it will basically detect SGX is there, and then basically it will build with the SGX support. So this is done at the build time or compile time. For this, yes, we have a patch. I modified the raster paint engine, intercepted the APIs, and made it to go into the Neon libraries. Yes, I did change it. And I know it was a bad hack, but it gives you performance improvement. So far, we don't have a good solution for it, but hey, it's accelerated still.
Is it going upstream? Is this kind of stuff being submitted upstream to Qt?
We are trying. We are working with Nokia, and you will see it. So you can, I'm not sure if BeagleBoard is having it. Frank, are you aware? Yeah, so it's a standard download, so you can definitely put it on BeagleBoard. However, please do read the licensing agreement of using those libraries before you use it, because the people from which we got, we have agreement that it can be used only on TI devices. So if you're using BeagleBoard, it will be good, but I'm not sure about other.
How about OMAP hardware?
You cannot use that. Of course it is. You can use it on OMAP. Nokia phone is OMAP based, by the way.
So I want to thank Varun Shah for the presentation. Thanks for coming to DevDays.